Video, I'm going to show you how to perform a two-tailed test for the population mean. So here's an example where the researchers claim that the average time spent in cardiovascular exercises by adults over 40 is exactly 42 minutes per day. To verify the claim, you have a sample of 8 adults, all of them age over 40, and the time spent on them on cardiovascular exercises on a daily basis as shown below. We have to perform a hypothesis test using a significance level of 0.1. Now, since the claim is exactly equal to 42 minutes, and since we are claiming about the average time, so the parameter we are testing for is mu, and mu is the average time spent on cardiovascular exercises by adults over the age of 40. So the claim here is mu is equal to 42. I observe this statement, then I determine the null and the alternative. So the null hypothesis will always have the equal to sign by definition, so this statement must go over there. The alternative hypothesis, which is H1, is the direct opposite of whatever statement you have in the null. So since the null is mu is equal to 42, the alternative is mu not equal to 42. So that would be our first step in the hypothesis test that we are performing. Since the alternative is not pointing in one direction, it's not equal to, this is a two-tailed test. If it's pointing to the right, then it would be a right-tailed test. If it's pointing to the left, then it would be a left-tailed test. So, alpha is given in the problem, alpha is 0.1. If alpha is 0.1, that would imply 90% confidence in our conclusion. So that is step 2. Step 3 is to find the test statistic. Now, in order to find the test statistic, which is given by this formula, T is equal to x bar minus mu naught divided by S over square root of n. Mu naught is the claimed value, so in our case, 42 is mu naught. I plug in the numbers. I have mu naught, which is 42. I know n, which is 8, but I do not know the mean and standard deviation. But you can find the mean and standard deviation using a calculator. So press on and press start. Go to 1, start entering the observations. 41, 40, 54, 60, excuse me, that's a 60, 30, 45, 35, and 40. So now that the data is here, I can press second mode to exit and go over to start, calc one variable statistics of the list 1, which contains our data. Press enter and you'll find that the average is 43.125. so x bar is 43.125. You can round it and write it as 43.13. The standard deviation S is the fourth number, it's 9.775. You can have it in 2 decimals as 9.78, and that's all we need right now. So I know the mean, I know the standard deviation, so I could plug it in my formula. I would have 43.125 minus 42 divided by 9.78 over square root of 8. So if you type this in the calculator, you'd end up getting 0.3268, which is approximately equal to 0.327, but you can keep it as 0.3268. There is nothing wrong with that. So step 3 is calculating the test statistic, and we have found the test statistic. So the next step in the test is to identify the distribution of the test statistic. So since this is a test for mean, the test statistic has a t-distribution with parameter, which is given by the degrees of freedom. In this case it is just n minus 1, so we will get 8 minus 1, which is 7. Okay, step 4 is done, and step 5 is the conclusion part. So conclusion can be obtained in one of two ways. So you could either go with the critical value method, where you will find the critical value, or you can use the p-value method, where you'd find the p-value. So p-value is a probability, critical value is a quantile. So keep that in mind. So critical value is a quantile, p-value is a probability. So I'll do both methods here. Let's start with the critical value method. Since this is a two-tailed test, the rejection region is on both tails, so on the right hand side as well as the left hand side. So that is the t-distribution. The t-distribution looks more or less like a normal distribution. The area of the rejection region on both sides is alpha over 2. You may ask why. Because the area of the rejection region, no matter what test you perform, must equal to the value of alpha that we chose. So since I have two rejection regions, and when I sum the areas, it must sum to alpha, so it has to be alpha over 2 on each side. So the tail area on the right tail is 0.05, the tail area on the left tail is also 0.05. That is the critical value on the right, and that is the critical value on the left. So left critical value, right critical value. So the left critical value is denoted by t. The area below is alpha over 2. Over there, the area below is 1 minus alpha over 2. If the area above is alpha over 2, the area below would be 1 minus alpha over 2, because the area under the curve is 1. So that value over there is denoted by t alpha over 2 comma df. That is denoted as 1 minus t sub 1 minus alpha over 2 comma df. You don't have to find both values. You find one, you multiply by -1, you get the other critical value. So I'm going to find the one on the left hand side. So to find this using a calculator, you will just do inverse t, the area below the critical value, which is 0.05, comma the degrees of freedom, which is 7. So go to your calculator now and press second vars, and you will see option 4 is inverse t, and 0.05 is the area below, comma 7, and press enter. The critical value is negative 1.849. So on that, if this critical value, which is on the left hand side, is negative 1.849, 1.849. The one on the right is positive 1.849 because 0 is in the middle and the distribution is symmetric. Now, where does the test statistic lie? Well, from our previous part, step 3, the test statistic is 0.327, and 0.327 would lie right over there. So that is our test statistic. So T is 0.327. So did the test statistic fall in the rejection region? So clearly the test statistic does not fall in the rejection region. Therefore, with 90% confidence, we fail to reject the null. So that is my conclusion. Why? Because the test statistic did not fall in the rejection region. The rejection region starts at 1.849 and beyond, or negative 1.849 and below. So the test statistic is 0.327, and 0.327 does not fall in that region, in either of those regions. Therefore, we fail to reject the null. And that is how you find the conclusion using a critical value method. But if you want to use a p-value method, you have to find the probability. So how do we find the p-value? So the p-value is dependent on the type of test, and for a two-tailed test, the p-value is 2 times the area above the absolute value of the test statistic. So the test statistic is 0.327. The absolute value of 0.327 is still 0.327. So that is my distribution. And 0.327 is over there. I'll find the area above it, and I multiply the area by 2, I'd get the p-value. Well, the area under a continuous distribution is a probability. Therefore, to find this probability, we will make use of a CDF function. But the test statistic has a t-distribution, so we have to use a t-CDF. So to find that area, we'll just use t-CDF. Starting point is 0.327. Ending point is E99, and followed up by the parameter, which is the df. So we could do that using the calculator. We'll do the same thing again. Second vars, scroll down to number 6, you find TCDF, select TCDF, starting point is 0.327, comma, excuse me, it's 0.327, comma, the ending point is E99, and that E is obtained by pressing second comma, and you get E99, comma, the degrees of freedom, which is 7. Close paren, press enter, that area is 0.3766. But the p-value is 2 times the area that we found, so 2 times 0.3766 is close to 0.75. It's 0.7532. So now that we have the p-value, you have to ask a question: is p-value less than or equal to alpha? If you say yes, you reject null. If you say no, you fail to reject null. Clearly, p-value is 0.7532, alpha is 0.1 given in the problem. So is 0.7532 less than or equal to 0.1? Clearly the answer is no, so we fail to reject null. It is the same conclusion that we had previously. So if we go back to our question, the null in the very first step, the null was mu is equal to 43, and the alternative is mu not equal to 40. Excuse me. The null is mu is equal to 42, and the alternative is mu not equal to 42. And in both the critical value method as well as the p-value method, we concluded that we failed to reject the null. So that is the null, that is the alternative from step 1. And clearly we failed to reject the null, so the data is pointing toward the null. So the null is more likely to be true. And since the researchers claim that the average time spent by adults over 40 in cardio or on cardiovascular exercises is exactly equal to 42, the claim was actually represented by the null, and we found evidence toward the null. Therefore, the claim is true. It's likely to be true. So what does the p-value mean? The p-value tells you if you hypothetically rejected the null, what are the chances that you'll be rejecting it merely by chance? Or if you rejected the null, what is the amount of error that you'll be making? So if I rejected the null, then I'll be making a 75.32% error. Now that is a lot of error. That tells me that I should not be rejecting the null, and hence our conclusion that mu is equal to 42 is more likely to be true. And since the data is pointing toward the null, and the claim is also represented by the null, we can conclude that the claim is true. That is how you perform a two-tailed test. But if you want the calculator to do all the work for you, you can make the calculator do everything. So press start, go over to tests, and we are performing a t-test, so select option number 2, and we have the data in this problem, so it's blinking on data, so we will select that, and it's asking for mu naught is 42, and our data is in list 1, so we can leave it as is. Now we have to pick the type of test. So the first is a two-tailed test, the second is a left tail, the third one is a right tail, and clearly we're performing a two-tailed, so we'll select that. And if you hit calculate, you get this information, and as you can see, the test statistic is 0.3255. I had it as 0.327, but they're okay because they're very close to each other. The p-value that I had was 0.7532, and the calculator has 0.7543. It's still fine, and you can see that the mean and the standard deviation are the exact same values that we had previously. So that's how you calculate or perform the test directly using a calculator. Now, the calculator can also perform a test if you just provide the data. Provide the statistic and not the data. So if you select option number 2, instead of data, if you go for statistics, select statistics instead, this time it's going to ask for the mean and the standard deviation. But the calculator already knows that we used the data from list 1, so it automatically plugs in the mean 43.125 and the standard deviation 9.775 from the data in list 1. So everything else remains the same, and if you scroll down and press calculate, you'd end up getting the same answer that we had previously. You can also ask the calculators to sketch out a p-value for you, and to do that you repeat the process, but only this time instead of doing calculate, you'd press draw and press enter, and it's going to neatly sketch out the the p-value. And as you can see, the p-value is on both sides because this is a two-tailed test, and if you add the shaded area on both sides, you would get 0.7532. So in our approach, we actually found the area above the test statistic and we multiplied by 2, the calculator is doing the same thing. It is sketching the values on both sides, or it's sketching the area on both sides, the right tail as well as the left tail. So that is how you perform a two-tailed test for population mean manually as well as using a calculator. I hope this video was useful. Thank you for watching.